If you notice, we already moved on from the getting us ready for algebra. Now we are in 8th grade, the Common Core Standards, and we're looking at number and quantity. And we're going to focus on point 2, which is using the properties of exponents. So today we're going to start with multiplication, and then we're going to continue tomorrow. So there's 3 different types of properties that I want to address, but we're going to get to one today. Okay? The other standard is the math practice standard. Last week we worked on math practice standard number, what was it, number 5, which was use appropriate tools. We used the tiles, remember last week? This week we're going to focus on math practice standard number 6, which is attend to precision. So for those of you that forget your negatives, or forget to finish with a decimal to the 100th or whatever the case, this week you're going to be working on that. Okay? Also, when I ask you for sentences, same thing. Finish your sentences completely. Don't say, oh, because I said so. No. Make sure you respond in a full sentence. Okay? All right, let's continue then. So with that said, our objective for today, I can simplify exponential expressions using the multiplication properties of exponents. Let's read it together. 1, 2, 3. I can simplify exponential expression using the multiplication properties of exponents. So, by now, we are experts and we should know the concept for today. Is that correct? Tell your neighbor the concept for today. That is correct, and that's going in the center of your Ferrier model, or the box, exponential expression. So that goes here. And let me show you the definition. Definition. Exponential expressions are numerical or variable expressions raised to a power greater than 1. Numerical or variable expressions raised to a power greater than 1. Exponential expressions are numerical or variable expressions raised to a power greater than 1. Numerical or variable expressions raised to a power greater than 1. Numerical or variable expressions raised to a power greater than 1. Numerical or variable expressions raised to a power greater than 1. Numerical or variable expressions raised to a power greater than 1. Numerical or variable expressions raised to a power greater than 1. Numerical or variable expressions raised to a power greater than 1. Tell your neighbor the definition, please.
Numerical or variable expressions raised to a power.
That was funny. So, check this out. I'm going to use a definition so I can give you the examples one by one so that you understand where we're at and where we're moving from here. So here we go. You'll finish copying in a little bit. I'll give you more time. Pens and pencils down. Eyes up there. Check this out. So the definition says numerical or variable expressions raised to a power greater than 1. Let me show you the first example. Here I just see a number with an exponent. Since they're only using number, this is called a numerical expression. A numerical expression is when they only use numbers in operations. So do you agree this is a numerical expression? Yes. The power, it's greater than 1. What is the power here? 3. So therefore, it is an exponential expression. It's a numerical expression greater than 1. Hold on before you copy. Pay attention. Here goes the next one. X to the 6th. This one has a variable. Therefore, this is called a variable expression. Does it have a power greater than 1? Yes, this one has a power of 6. And so on and so forth. Look at this one. This one has numbers and variables. But since it has a variable, it overpowers just the numerical, so this one's called a variable expression. And does it have a power greater than 1? Yes. Look at this one. X squared y cubed, variable expression. Does it have a power greater than 1? Yes. Copy those, please. Any questions with exponential expressions? We got it, right? Let me show you some non-examples. We got 2 cubed equals to x. A times b squared equals to 12. And negative 3 plus x. So, think about it. If these are expressions, they're exponential expressions because they have numerical variable expressions with powers greater than 1. First of all, why are these not, and why is this not? an exponential expression. Think about it. Talk it over with your neighbors. Why do you think these might not be? Once again, these were equations. These are not. These are expressions. Expressions do not have equal signs. This one was an expression, but the exponents were not greater than 1. That's why there are not exponential expressions. Therefore, expressions only, exponents greater than 1. Are we there so far? Okay? Underneath that, let's copy 3 steps, simple steps that we're going to be looking at today. So, steps. Identify if the exponential expression is a product of powers, power of power, or power of products.
What?
Step 1, identify the exponential expression as a product of power, power of power, or power of products.
What?
Identify the exponential expression as a product of power, power of power, or power of product. Step 2, use the appropriate property to compute. And step 3, simplify. Step 1, identify the exponential expression as a product of power, power of power, or power of product. Step 2, use the appropriate property to compute. And step 3, simplify. I know it sounds like a tongue twister, right? Imagine if you said that like 3 times fast. Copy that, please. Alright, so here we go. So, we got our steps down. Now, something to remember, whenever you see a number without an exponent, you're going to write an exponent of 1. Whenever you see a variable without an exponent, you're going to write an exponent of 1, and so on and so forth, yes? On the Q side, on the Q column, I want you to write commutative property of multiplication, and then leave a space, and then you're going to write associative property of multiplication. So leave plenty of space for the commutative property, and plenty of space for the associative property. And I'll go over a couple of examples for those. Yeah? Do you remember? Oh, you got it?
Yeah.
All right, here we go. So, commutative property of multiplication. Now, the word commutative comes from the word commute. For example, there are some teachers here on campus that live in Yuma, and every day they commute to Imperial for rallies, yes.
Miss Denning, doesn't she live in?
Yeah. So what does the word commute mean?
A long street.
Yes, a long travel. Yes. So yes, commute means to travel. So what the commutative property of multiplication means is that when you have different numbers with multiplication only in between, it doesn't matter which way the numbers travel, commute, the product will be the same. Let me give you an example. Look up to the screen. If I had 10 times 2 times 10 times 5, let's see what the product of this is. 10 times 2, that's 20. Times 10, that's 200. Times 5, 1,000. So, what if I said I'm going to make the 10 commute and the 2 commute? So this becomes 10 times 10 times 2 times 5. Do I have multiplication throughout? Yes. So let's see if the product is different. What is 10 times 10? Times 2 times 5. The product is the same. So it doesn't matter how you order the numbers. If it's multiplication throughout, the product will be the same. Copy that, please. Fairly simple? Yeah, right? Now, these properties are not the multiplication properties of exponents. But within those, we're going to be using these two, commutative and associative. Now, this is just a refresher. The commutative and associative property, including with distributive property, you guys were learning ever since you were in 3rd grade. Remember that, when they started introducing these properties back then? Yes? No? Okay, never mind. Next, associative property. Associative property comes, or the associative comes from the word associate. For example, if I had, everybody look up please, if I had 10 times 10 times 2 times 5. This reminds me, an easy way to remember this is, let's say you are at your house, or you are somewhere, and you are the 2. You are this one. And then here come your friends, and then all of a sudden you have a little cousin or your little brother or sister that they always want to hang out with you. And you want time for yourself with your friends, right? You're like, really? And then you're like, can you go over there with mom or dad or whatever, right? And they go and they come back crying, right? And they're like, let them stay here. All right, fine. So that means you have to let them associate with you, right? So what this says, everybody look up, if I was to associate the 2 with the 10 and start my operation here, the order in which I associate the numbers, the product will remain the same. Let's see. What is 10 times 2? 20. What is 20 times 10? 200 times 5? It's still 1,000. And if I was to start by associating the 2 and the 5, that's 10 times 10, 100 times 10, it's still 1,000. So it doesn't matter which way you associate the numbers, if there's multiplication throughout, the product is the same. Does everybody understand the difference? Commute, they need to move. Associate, you need to associate numbers differently. But the product is the same. Copy that, please. So, everybody got it? So once again, these are not the multiplication properties of exponents, but these are properties that we're going to use within that. Okay? So let's get started. Turn your papers over to the back side of your Cornell notes. At the top left of your Cornell notes, above the frame, you see that it's framed? Above the frame, I want you to write product of powers property. Product of powers property at the top left corner. And then underneath that, I want you to write example Q. Okay? So, for example Q, I want you to copy the following. 2 times 2. Underneath that, 2 times 2 to the third. Underneath that, 2 to the third times 2 to the fifth. Okay, pens down, pencils down, eyes up here. So, let me go ahead and use the product of powers property. Once again, I'm not going to give you the rule. Your noodle has to come up with it. Here it goes. So pay attention up there. I'm going to use a property, and if I simplify this, this becomes this. If I simplify this one, this becomes this. And if I simplify this one, this becomes this. Are we there so far? Now, part of the whys is because I said, remember, whenever you have a number without an exponent, we're going to write the exponent of
1.
Tell your neighbor why this happened. Go. Okay, copy that please, and I'm going to simplify this one more step. This becomes 4, this becomes 16, and this becomes 256. Copy that please. Then we're going to do it with algebra. Alright, so by now your noodle already has a rule, right? Okay, use the rules to simplify these following ones. X times x, x times x cubed, and x to the third times x to the fifth. Simplify those. Go. You have 30 seconds. Okay, I heard x to the second, x to the fourth, x to the eighth, and you wrote the little ones there, there, and there for the variables that did not have an exponent. Is that correct? Yes, Mr. Q. All right, good. So, let's do one more. Underneath right here, it's still part of example cube, but write this down. It's 2 to the 4th times x cubed times 2 times x to the 8th. Just copy that, and then I'm going to show you the steps to deal with these. So, pens down, writing utensils down. Let me go over this, but before I continue, your noodle already made up a rule, is that correct? Your rule to get to here was what? Let's see, who wants to share? Yes, over here in the back.
Add the exponents.
Okay, add the exponents. That's close, but I still saw Kylie raising her hand.
Oh, that's exactly what I meant.
Okay, so they said add the exponents. But notice that's only, what do you notice here? Yes. The same base. Did everybody hear that? So I heard add the exponents, same base. So what would be a rule? Think about it. Only add the exponents if it's the same base. Does everybody agree with that rule? Okay, so far so good. So let's see. Everybody look up. Look at this example. Look at these two. I'm multiplying 2 to the 4th and x cubed. Can I add these exponents?
No.
Why not? Different bases. Therefore, can I multiply the 2 to the 4th times 2?
Yes.
And could I do something with the exponents? Yes. However, in order to do that, I need to bring the 2 over here and the x to the 3rd over here. Think about it. What property is that? Yes.
The commutative property.
Commutative property of multiplication. So check this out. Draw an arrow, and let's rewrite this. 2 to the 4th times x, oh my bad. I did that on purpose. See if you were paying attention. Times 2 times x cubed times x to the 8th. Do you agree we use the commutative property of multiplication? Yes. Now that we have that, check this out. What is this called? Tell your neighbor. That is correct. Associative property of multiplication. You see how we're using other properties within the property? Yes, Mr. Q. All right, good. So let's simplify this. This becomes, oh, what did I forget to do? Oh yeah, to write a 1 here, okay? So this becomes 2 to the 5th times x to the 11th, okay? So notice that I did not write the multiplication sign here because it's implied whenever there's a number and a variable side by side, what operation? Multiplication. Are we there? So let's see. What was 2 to the 4th? 16. So what is 2 to the 5th?
32.
32. Bring down the x to the 11th, and now this is simplified. This is simplified. Everybody got it? Fairly simple?
Yes.
Okay? Therefore, let's write our rule. Put a little asterisk right here. Draw a heart. Oh. So, let me get you started with a rule. I'm just going to get you started with a little, the wording. When multiplying, what are we multiplying? What was our main concept for today? What was it? Exponential expressions. But what kind? What did we say were these? Yes? No. What did we say these had in common, all these? We're multiplying exponential expressions. Close. Let's see, Kylie?
You can only, add the exponents that have the same base.
So you're going to write, when multiplying exponential expressions of the same base, comma, what do we do? Yes? What? Add the exponents. Does that make sense? Yes, and at the end just write 10 cubed. Everybody got it? Yeah. Get it? 10 cubed? 10 cubed? It barely hit? Yeah? Alright. So, any questions with this? So far so good? Okay, let's do example number 1. Copy this down, please. It says, find the product of powers. It says, simplify 3 to the 2nd times 3 to the 5th. And for B is 2 to the 4th times 3 to the 4th times 2 to the negative 2 times 3 to the 2nd. Copy that and see if you can do those by yourself. Go. Okay, let's see. This one. Do they have the same base?
Yeah.
Yes, so we have the exponent. This is 3 to the 7. However, if we simplify it, this becomes 3 times 3 times 3 times 3 times 3 times 3 times 3. This is 9 times 9 times 9 times 3. This is 81 times 9 times 3. This is 729 times 3. So this becomes 7, we got 2, 6, that's 8, that's 21. So 2,187. Hands if you got that. Okay, not bad. So, you're saying, man, that's a lot of computation. I know, right? Look at this one. Who saw that we needed to move stuff around? Yeah, right? So therefore this becomes 2 to the 4th times 2 to the negative 2 times 3 to the 4th times 3 to the 2nd. And what property did we use there? Commutative property of multiplication. From there we associate these two together. These two together, that's the associative property of multiplication. This becomes 2 to the 2nd times 3 to the 6th. So let's see, what is 2 to the 2nd? 4 times, what is 3 to the 6th? 729. And if we multiply these, 9 times 4, that's 36. I got 3. 2 times 4 is 8, plus 3, that's 11. I got 1. 4 times 10, 28, plus 1, that's 29. 2,916. Hands if you got that. Bam, now we're rolling. How we doing? You doing alright? Okay, let's do another one. Copy this one. Example C and D. Go. You have 40 seconds. Okay, let's see. What property do we need to use here to move stuff around? Commutative. This becomes Q cubed, Q to the 6th, R to the 2nd. Associative, Q to the 9th times R to the 2nd. Hands if you got that. Okay. This one. Let's see. Could we move stuff around to keep the positive with the positives? Yes, commutative. So I'm going to do n cubed times n to the negative 4th. So these two become n to the 4th times n to the negative 4th. So this became n to the 0. Hands if you got that. Okay. So for homework today, there's a worksheet in the back. Worksheet. You're only going to work on problems 1 through 70. Not just kidding. 1 through 7. 1 through 7. You guys are like, what? Anyways, grab a worksheet on your way out. Have a good one, everyone. Enjoy your homework. See you guys tomorrow.